I believe that everybody would be like in the earlier session. I believe that you would have discussed something about what exactly descriptive statistics and descriptive statistics is and how it is actually used for our research and all these things. Okay. Okay. Yeah. Okay. And so descriptive part of your statistics or descriptive part of your data is already over, and now we shall be continuing with our inferential part of the statistics. So in descriptives, I believe that you would have learned a lot about how tables are formed, how the data is being grouped in different forms, uh, how it is managed properly, how it actually how you make different. And I believe that something about normality as well you people would have discussed, no? I believe normality of data has already been discussed. If anybody can answer about it. Normality of the data has already been discussed.
Parametric distribution is what normality is, sir?
Yeah, exactly. So I believe that it has already been discussed yesterday only, no?
Yes, sir. Yesterday, ma'am discussed it.
Okay. Okay. Thank you. Thank you so much. So we shall discuss a little bit about normality, not exactly right now, but later on. So let us discuss the inferential part of the statistics. So inferential statistics is basically, it is, you can say that it is one of the branches of statistics, and it makes, we generally use different kind of analytical tools, and we draw certain type of inferences out of for the about the population of the data whatever we do have. Okay. But what we do is we use a sample for this, and I believe that how to draw the sample and all these things you have already discussed it properly. So that part I won't be continuing right now. Not only this, that there are two basically different types of inferential statistics are, in which first one is like hypothesis testing. Generally they are not being distributed like this, but but just for the sake of understanding it, we bifurcate different kind of inferential statistics also in two different parts. So the first part which is uh, which is called hypothesis testing. Okay. And the second part we call is like prediction. Hypothesis testing and prediction part is over there. So that prediction part is being taken care of by regression analysis. I believe since you people are already in statistics, you people are already into data analysis and all these things. So you would definitely, almost all of the faculties, they know very well about what exactly regression is and how it is being calculated. And you would have learned it, or you would have taught regression in statistics, in the subject interest statistics, either to the the postgraduate students. So that has already been with you, like regression. As of now, we shall try to discuss a little bit of regression as well. However, we shall be discussing about hypothesis testing on more. Okay. So there are two different types of things now in hypothesis testing and in regression. So in hypothesis testing, there are different types of tests. There are different types of tools available, different types of tests available. In general, we do have different groups of data. Or whatever data we have, we group it into different parts. We group that data. We make groups on the basis of gender. We make groups on the basis of ages, or we make groups on the basis of the profession, or different type of demographies are there on the basis of which we used to make groups. So we will have different types of groups. We at some part we would be having either 2 or 3 groups. At other part we would be having some 3-4 groups or that. So there are different types of groups available. Our discussion is what exactly hypothesis testing is and how we used to test. So hypothesis testing is basically what we do is we test the hypothesis. Hypothesis, I believe you would be already knowing this. Hypothesis is something like it is an assumption about the group, about the population, and we just test it whether our assumption is correct or not. Okay, and I believe that we all know that this there is a null hypothesis, there is an alternative hypothesis. Null hypothesis is being said in general it is a negative hypothesis. Okay, and we draw conclusion on the basis of certain test, certain value, and its value of whether the differences are significant or not. So all these things I believe you people would already be knowing. Okay, so now let us start off with what exactly data is and how we should calculate what different types of tests are. Okay, so the first thing that we shall be calculating today is the very first thing is a single type of data which we generally have and how we use that single type of data. Okay, so just a second, I am sharing my I would be sharing my this screen right now with you people. I believe that you people would be uh, seeing what exactly is going on my screen. So I once again I am assuming as if this all this like how to prepare data in SPSS and all these things that has already you have already gone through all these things. So I won't be taking that part. We shall only be discussing about how do we have how we apply different kind of tests. Okay, so this is I am sharing my screen with you. Just a second, please hold on. In the meantime, let me first this SPSS we have to start. Okay, okay, so I have started this software, and here I am sharing my screen with you people now. So there is some sort of error while sharing the screen. Just a second, let me try it once again. Can you see the screen? What is going on the screen right now?
No, sir.
No, you are not. Just a second. Actually, some sort of error occurred while I was sharing the screen. So let me do it once again. Okay, once again, some kind of is occurring again and again. One last time I'm trying, otherwise I will share the whole screen, don't worry. Data. Okay, so let this don't be the data. Let me show you this data. Okay, So first, let us start up with this data. Just a second. Let me check which screen is visible to you, or let me share my entire screen with you. That would be easier, I believe. Okay. Just a second. Okay. Now, is it visible now? Whatever is going on the screen, it is visible to everyone. Is it okay? Since I'm facing a little bit some kind of data issues, hence, with all your due permission, I'm putting off my camera so that it would be easier for me to this, like, communication would be easier as the data will flow easily. So I have, thank you so much. So here it is, the data we do have. What data it is? Actually, it is marks, and I believe that you people already know this thing. This is how we define the data. We define the variable. So this marks, it is a numeric, it is width is 8, decimals are 2, label we can say here it is, once again it would be marks, marks of, or whatever you want to have. Like, it could be simple marks, could be there, it could be like different subjects or so. So values, there is no specific value assigned to it, no missing value. This would be right aligned, it is on a scale basis, and it is an input variable. So whatever it is there. Now, what exactly is, let us go to data view once again, and here marks are there. Now, what we do first of all is, you have collected a data. Let us take a very small example. With this data you are seeing right now, let us take a small example. Okay, these are marks. Now you want to know whether, what exactly is the tendency of these marks. Okay, whether the students have got an average marks, what exactly is the tendency of these marks. If there is some threshold limit, like if there is a threshold limit, like anybody securing less than 60 marks, less than 80 marks, less than 70 marks, less than 50 marks, then that person would be disqualified some by something or other thing, whatever it is. So having these kind of threshold limits, what exactly is required is, you need to know what is going on, what exactly are the marks secured by the students. So this is the data about somewhere 51 students securing different kind of marks. Now what happens is, what exactly you need to use, which tool exactly we need to use. So the first tool that we shall be using will be a t-test, students t-test. Okay, so this will be a student's t-test which we shall be using. And why it is used? It is used for two different things. First thing for which we use it is to know what exactly the central tendency is. Okay, I'll be showing you how it is being actually implemented, how it is being calculated, what are the values, and how we use it. So the first thing is, what exactly is the central tendency, what exactly is whatever the data is depicting right now. Okay, second thing for which we use it is whether the threshold limit is being crossed or not, or the marks are somewhere, whether they are near to threshold limit, whether they are more than threshold limit or less than. So what happens whenever we prepare a hypothesis for this, for this tool, this test, the students t-test, since we have a single data, a single variable, single data, we call it one sample t-test. Is it clear to everyone? I believe that since now I won't be looking at this part, like here where we do have this the screen meet. So I shall be moving to SPSS only. I request you people, like here some of them have written something, but it's okay. So I won't be coming here. I believe somebody can please answer me by just putting your microphone on. Okay, so let us come back here. So marks over here. Now what happens is, first, so as I told you, there are two different things. So first things first, let us try to check what exactly is the what exactly the data is saying. where the marks are being going or so. So just come to here over analyze, then come to compare means, and come to one sample t-test. Here we have one sample t-test. Marks is the in the left hand box. Marks shall be, since we have only one variable, hence it has been put over here. But in case of more variables, you would be finding more variables over here, and you need to check which variable you want to test. So this we are testing, and simply we are not doing anything. We are not doing this test value is written over here, but we are not using it right now, because what exactly we are doing is we are just testing what exactly the marks are telling us, how what is the distribution of marks, how it is coming to us. So just simply nothing, like in options you won't find any specific thing, bootstrap, nothing else. You just have to click on OK, and I believe that you people can see result. This is the result side of the SPSS file. So on result side and on the left hand side, as you people know, you shall be looking after about what exactly the log is, how the commands are being executed. On the right hand side, on the bigger box, you can see the t-test has been implemented. The first thing you can see is one sample statistics. So what exactly the statistics says is there are 51 samples. The mean is 63. The mean is 63. The standard deviation is 6.71, standard error. All these things are over there. Okay. And then this one sample t-test table is over here. So marks, t value is 66, degree of freedom is 50, the significance is 0.000. The hypothesis in this case would be there is no difference in the marks. There is no significant difference in the marks obtained by the students. This shall be the hypothesis. And since our significant value is 0.000, which is below our threshold limit, I believe that you people already know about the threshold limit of the significance. The level of significance, it is 5%. We generally test it on 5%. It could be, depending upon the data, it could be more, it could be less. So in certain cases, you mention the significance value or the significance at 1% level as well, and in general we keep it at 5%. Okay, so the significance value would be, if the significance value, this is the p value which we generally used to call. So this significance value is less than 0.05. 5% is 0.05, 5 divided by 100. So since the value is 0.05, hence our null hypothesis, which states that there is no significant difference in the marks obtained by students, cannot be held positive. It means that we have to reject our hypothesis that the marks are different. There is significant difference in the marks obtained by students. This is what something have any kind of observation. You do not have any kind of assumption about the marks. Okay, now what happens is, let us assume something. Let us have an hypothesis. Let us assume something about the marks, and let us assume as if the whole class has got something like first division. This is what you want to say, or alternatively you want to check whether the students have got 65% marks or not, whether the students have got 70% marks or not. So what we can say, so for this, what we need to do is we need to assign a value. I believe you people would remember when I started. So analyze once again, go to compare means, go to one sample t-test, and here in the test value you need to put the value which you want to test. What exactly you want to test, whether you want to test that all the students have got 60 or more than 60 marks, or 60 marks. Because what happens is, when we are making hypothesis like this, it would be a two-tailed hypothesis. It can be positive, it can be negative. So the answer which comes would be either positive or negative. Okay, so either positive or negative means, if you are stating a specific value, the hypothesis would be the marks obtained by students is not 60. Okay, so if number of students would not have secured 60 marks, definitely the hypothesis will be rejected. But then rejection would be on the basis of two different answers. If the answer is more than 60, it would be rejected. If the answer is less than 60, it would be rejected. Okay, so let us do one thing. Let us put the value as 60. Now let us check what exactly the answer comes. So here the second t-test. Once again, you can see what exactly it is. The one sample test, this t value earlier, which was 66.979, has reduced to 3.189. And this significance value, which earlier was 0.000, I believe that you people can see this. It is
Yes,
visible
sir.
to everyone.
Yes,
Yes, sir.
Thank you.
It is visible. Yes, sir.
Thank you so much. Thank you. So earlier, which was the value, which was 0.00, has come up to 0.02. Although at this point of time also, it is less than 0.05. Hence, our hypothesis will once again get rejected. And the hypothesis was whether our students have got 60 marks. The average marks of the students is 60. But no, our average marks of the students is not 60. Okay, let us try it once again. Go to analyze, go to compare means, go to one sample t-test. Earlier it was 60. Now let us keep it 66. And let us see what happens. Once again, simply click OK and you will get the results. This is the first result, which you can see. This is the second result. And now this is the third result. I believe you can see the t value has been, now you can see it is in negative form. Minus 3.189. So it is negative. Okay. Degree of freedom will remain same. However, significance value P, it is still 0.002. So the value is neither 60 nor 66. Okay. Now let us do one thing. The value which already is there. What happens if we put our value very near to it? Okay. What happens is, there is an example. I'm taking just an example. We all do have laptops. Okay. What we need to know is the weight of the laptop of a specific size. In production line, suppose a normal type of laptop, a small 14-inch screen laptop is being prepared, is being like they are producing it. And the weight should be somewhere around 2 kg, 1.5 to 2 kg or 2 kg. The weight should be 2 kg. Now what happens is you will get the data for whole day, suppose the production, the whole day's production is somewhere around 100 laptops, and you get the data that for the 100 laptops this shall be the data, in the very similar fashion in which here you are getting the data of marks. So you have got a data of 100 laptops with their respective weights. Now what you want to know, you want to know whether the weight is as per the standard weight or not, and the standard weight is 2 kg. So whether the weight is with the standard is matching with the standard weight or not, there might be certain differences. We don't find there won't be any much differences. Differences would be there, but the differences should be significantly less. They should not be significantly more. So what will happen is, here you will apply this one sample t-test. Okay, let me apply this one sample t-test once again. If suppose the marks obtained by the student, what if the marks obtained by the student is somewhere around 62, 60 is 62. Let us check once again. Analyze, go to compare means, one sample t-test, and let the value be 62. What happens if we keep it 62? Here is once again, you can see the value. You can see the value of t-test. You can see the table of t-test. And once again, let me remind you the hypothesis. There is no significant difference in the weights of, in the marks of students. So the marks of students are somewhere around 62. The average is 62. And here what happens is, now I believe you people can see the significance value. The p value is 0.293. Now what happens is, since it is more than the threshold limit, the threshold limit is 0.05 and the value is more than our threshold limit. Hence, our hypothesis, what happens to our hypothesis, whether it will be rejected or accepted?
Rejected.
Answers?
Rejected, sir.
No, not rejected. Our hypothesis will be accepted over here. because the significance value is more than 0.05. The value is 0.293. Our value is, the significance value, p value is 0.293, and it should be less than 0.05. However, the value we have got over here is more than 0.05. Hence, our null hypothesis will be accepted.
Okay.
Okay. And what is the null hypothesis? Null hypothesis is average marks are somewhere around 62.62. So the marks obtained by the students and 62, there is no significant difference between these two, and hence the value is 0.293. So our null hypothesis that there is no significant difference between the marks obtained by students and 62. So their average marks are somewhere around 62. This hypothesis holds good. Okay. Now once again, what happens is, let us. I believe that you can see, since the mean, we can see the mean over here. It is 63. What happens if you put the value as 63? What happens if you put the value as 63? Let us try it once again. So analyze, go to compare means, go to one sample t-test and put the value as 63 over here. What happens once you put the value 63 over here? There you will be able to see it. 63. Now you can see what is the significant value. It is the highest value ever achieved. 1.000. It means that exactly the mean is 63. So the average marks secured by the students is 63 only. And this is why the value, significance value is 1. Otherwise, it would range somewhere between 0 and 1. So it is 1. It means that the value is coinciding with the actual mean. So the observed mean, the assumed mean was 63. Actual mean was 63. Okay. Now let us do one thing. We have tested like the marks were somewhere. We have put the test value 0. Then the test value was 60. The test value was 66, 62, and 63. So the test value, we have tested almost all of them. Let us test a little bit lower value. Okay. So analyze, compare means one sample t-test. Let us go back to, let us make it 58. What happens then here? The average marks of the students are 58. What happens is, here you can see on once again in the significance column, you will find the value is 0.000, which is less than 0.05, which means that our null hypothesis that the average marks scored by the students is 58 stands rejected. Is it clear to everyone now?
Yes.
Okay. Thank you so much once again. So this was something about one sample t-test. Now there could be two different samples. Two different samples means there could be samples like these are the marks. Now what happens is, now you can have marks for, let us assume as if these are the marks of boys. We can similarly, we can have the marks for girls. Okay. So what happens next is, when you have, now you will have two different groups. Now you will have two different groups. One group is for boys, other group is for girls. Alternatively, what you can say is, one group can be for rural students, other one can be for urban students. One group can be for central board students, other group can be for local or the state board students. So whenever you have two different groups, then we used to apply independent sample or two sample t-test. Okay, so this was one sample t-test. Let us now apply the two sample t-test. Here it is. Just a second. This is once again, this is a newborn baby weight. So this is just it is only for the purpose of explanation once again. Let us take the example, quick example of this as well. Like analyze, go to compare means, go to one sample t-test, and then weight of the will be uh, test variable, and normal baby weight would be 2.5. So you just want to know whether all the babies are having the very same weight, whether the average weight of babies born between this, like this example, this data is somewhere around for 100 babies. So the 100 babies in a hospital, 100 babies, whether they born, they are from the standard weight or not. So the standard weight is 2.5 kg, somewhere around 2.5 kg. So whether they belong, whether the average weight of these kids, whether of these babies, whether it is 2.5 kg or not, whether they are healthy or not, just have to hit OK, nothing else, and you will find the results over here. The result is over here. The significance value is 0.000. Hence, the average weight. There can now here you will find that the hypothesis can be stated in two different forms. First one is all the babies, on an average, the babies born in a specific hospital or between a specific dates are healthy. And what happens is, in the background, what you will have to do, you have to compare the weights of the average weight of babies to the standard weight. The standard weight is 2.5. You have seen that there is significant difference. In statistical language, what we will say this, we will say is there is we found significant difference between the average weight of babies and the standard weight. And in general language, what you will say, that the weight is quite different. The weight is not standard weight. Now, once again, this will give you two different options, whether the weight is higher, whether the weight is lower. So here, this mean will be helping you. The mean is 2.8. So the babies born in that hospital are healthier as compared to the standard weight. If this mean would have somewhere around 2.3, 2.4 or 2.2 or somewhere between nearer to 2 kg, definitely what our hypothesis could be, the babies born are having poor health in place of good health. So this is how we use it. Okay. Now let us go to independent sample t-test or two sample t-test. Okay. We do have this, but let us use this this only. Let us use the marks once again. So I'm going to variable view. This will become marks underscore males, and we'll have marks underscore females. This will be numeric 8, 2 marks, nothing. Each and everything would be same. This scale, this input variable, each and everything would be same. So this will be marks boys, and this will be marks girls. So this will be there. Let me have some arbitrary numbers. So there would be somewhere around 50 marks or so. So what I'm doing is keeping the very same marks over here. Okay, just let us do one thing is let us make certain changes into it. Like 55, let us make it 56, then 53, then 62, 56, some changes, 69, then 54, make it 57, 64, make it 60, 64, make it 60, 54, make it 56, 66, make it 70, and 65, make it 63, 54, make it 58, 65, make it 68, and once again 66, make it 69, and I believe this much would be sufficient. Make it 67, make it 69, make it 80. Now let us do one thing. What happens is, now you have two different groups. Okay, so similarly you can have any two types of different groups. Any two groups you can have. So the marks for males and marks for females. Okay, what happens now is, we have to, just a second, I have missed a little small thing. Like this, these itself can be the marks of boys and girls both. Let me do one thing. Let us go to the variable view and let it would be the gender. Okay, and it would be like a nominal variable. Then it won't be numeric. The width can be same, and this would be gender. This would be marks once again. Okay, let us go back to the, like here it marks male. That would be the marks. Go to data view once again. So this would be the marks, and it would be genders over here. So gender would be 1 for girls and 2 for boys. So, all right, sorry, just a second. Just it was a little bit hurry. So let it would be, let it would. Okay, so now what happens is, now we do have two different variables. First one is marks and the second one is gender. We do not need any decimal value over here. You can put it 0. This will do. So let us come to data view. You will find gender over here and marks over here. Now what we do is go to analyze once again, go to compare means, go to independent samples t-test. A two sample is also called independent samples t-test. Go to independent samples t-test. What happens over here is marks will go to the test variable. Marks will be the test variables and gender will be the grouping variable. Gender will be the grouping variable. Options once again, but there is no need to take anything in the options. You won't find anything. What you need to do is you need to define the value of groups. Okay. So just a second. Let us define it somewhere first here. Okay. Here the values. Now let us define it over here. So we have decided 1 for girls and 2 for boys. Okay. Now let us come back once again to analyze, to compare means, to independent sample t-test, and what you find is once again marks is the test variable and gender be the group variable, but you need to define the groups. So the groups will be, group 1 will be 1, will be denoted by 1, and group 2 will be denoted by 2. You can have any number, whatever you want. You can have 0, 1, you can have 1, 0, you can have 3, 4, whatever you want to have. So we do not want any kind of cut point. Just continue over here and just hit OK. Nothing else. Not something very. Just a second. Here it is. Here it is. Now you can see these are the earlier. See one sample t-test. You can see a single small simple table. And here you will find a bigger table as compared to that. So the first one is group statistics. So we do have girls and boys 25 and 26. Their average values are already over here. And our hypothesis. What would be our hypothesis over here? There is no significant difference in the marks obtained by boys and girls. In a plain, simple language, we can say that the class has got normal marks. There is no significant difference in the marks obtained by boys and girls. This is the technical hypothesis. Statistical language will be like this. There is no significant difference between the marks obtained by boys and girls. Now what you see is Leibniz test for equality of variances. So what first you do is whether the variances of these two groups, girls and boys, whether the variances for these two groups are correct or not. Because I believe you can see in the very first table, you can see marks has been written over here. And then there are two different types of variable. There are two different types of values. There are two different types of calculations. The first one is equal variances assumed, and the second one is equal variances not assumed. So we need to know whether the variances are actually equal or not. Hence, this Leibniz test of equality of variances will be helping us. The value is, significance value is 0.457. In general, the hypothesis would be, the hypothesis would be there is no significant difference in the variances, and the value is more than the threshold limit, that is 0.05. The value is 0.457, which is more than the threshold limit, which is 0.05. Hence, we need to assume, we cannot assume that the variances are same, are equal. So we cannot assume equal variances. Now what happens is, here in rest of the table also you can see there are two values in each column. So now what happens is, once your variances are not equal, you have to take the values which are on the lower side of the column and not on the upper side of the column. Not the first row, not the upper row, but the lower row. Fortunately, the values are very much similar. Hence, we do not have to worry a lot. But at times, you will find that the values are different. Okay, but definitely you have to check for the variances. You have to assume, you have to keep your assumptions along with. If you assume as if the variances, and you can do also one thing, you can assume it, you want to take the values of upper row, you can directly assume, okay, we hereby assume that the variances are equal. They may not be equal actually, but you can assume them as to be equal. But here the variances are not equal. The variances are once again equal. Sorry, the hypothesis is accepted. There is no difference in the variances, and the value is more than 0.457. So the variances are equal. So the upper row, we shall be considering the upper row values. This significance value that you can see over here is 0.171, which is once again more than 0.05. So our hypothesis, there is no significant difference between the marks of boys and girls, holds positive, holds good. Is it clear to everyone? How we compare these two groups? What shall be the hypothesis and what is the interpretation? Is it clear to everyone?
For 80%, it is okay, sir. We understand.
80%?
There is little bit of confusion, I think.
Okay, please let me know what the confusion is. It would be better if we clear the confusion here only.
Sir, like I understand if it is not 0.005, then it is been thing. But what is that minus sign also, sir? Minus 1.38, minus 1.37. I don't understand that.
This minus sign is of not very much significance. We do not actually see this minus sign. What exactly is the absolute value of t? If the absolute value of t is more than 2, in that case, actually, then what we do is we compare it with the table value. Then the table value, you will find there is the p value, and this p value is over here in significance. It is two-tailed. So this is the reason why we generally ignore this t value and we concentrate on this significance value, p value only.
Okay.
And if this value is more than 0.05, what happens is we shall accept the null hypothesis. If this value is once again less than 0.05, we shall reject the null hypothesis. Now it depends how you are actually forming the hypothesis. If you are forming the hypothesis in a positive manner, accordingly, you just have to accept or reject it. If you are forming the hypothesis as negative hypothesis, like there can be a positive hypothesis as well. The null hypothesis can be positive. Null hypothesis is all the class has got equal marks. Boys and girls have got equal marks. This is a positive hypothesis. And similarly, in statistical terms, the null hypothesis, the negative hypothesis will be there is no significant difference in the marks obtained by boys and girls.
Okay, sir.
Okay. So,
Yes.
So this was about how if we are having two different groups, these can be any two different groups. If you are my subject is finance, so I compare nationalized banks with private banks with public sector banks with nationalized banks. So whenever you are comparing these two different type of banks, state owned cooperative banks and other cooperative banks, so when you are comparing these two things, Whenever you are comparing, whenever you are comparing boys with girls, you are comparing male with females, there can be anything. But wherever there are two different groups, in that case, what happens is you will apply this independent sample t-test. Now what happens? Now we'll have third type of data. Third type of data would be like, if you are implementing, you are going to implement something, you are taking a seminar, you are taking a workshop. So what happens is, I believe that you people would have definitely gone through all these things, but this is only out of focus as of now. Let me remind it to you. What happens generally is, when we organize a workshop, what happens is we take feedback. We generally talk to the participants in advance. What do you want to learn, or what you do not know? Okay. First, what we ask is what you do not know. Alternatively, what do you want to learn? It means that if this, with all due respect for everybody, it is not actually for your knowledge or for this. It is only for an example. Like, the participants of this workshop, if before this workshop, whether they are understanding this hypothesis, this t-test, or whatever we are discussing right now, whether they understood it earlier or not, and post workshop, pre-workshop and post workshop, whether they understood it or not. Now, whether you are able to understand how to frame the hypothesis, now whether you understood how to apply this t-test, whether you understood how to apply one sample t-test or two sample t-test or something else. So if it is so, that yes, now we can understand, now we can apply it in a better manner as compared to earlier, it means that the workshop is successful. But then once again, their pre-workshop experiences, perceptions, and their post-workshop experiences, we need to compare these two, and we compare it with the help of paired t-test. We compare it with the help of paired t-test. In paired t-test, what happens is your observation group will remain same. The participants will remain same. Pre-workshop, we will collect their responses. Post-workshop, we will collect their responses. If there is significant difference between these two, what happens will be, if there is significant difference, definitely the workshop is successful. If there is no difference in their knowledge, no difference in their perception, no difference in their experience, then the workshop is of no use. So that which test we generally use for this is paired t-test. Okay, let me show you the data for this paired t-test. We had it earlier as well. Just a second. Here it is. Paired t-test. Before and after. Here it is. This is the data. I believe here is the data. I believe you people can see. This ID stands for identification marks. This is the pre-data. This is the post-data. Whatever, it can be any type of data it could have been. So this is the marks before and marks after. And this is, just a second, let me expand it a little bit. You will understand what exactly it is. This is participant number only. So definitely this is something about, we would have conducted some workshop, and this pre-data is the pre-workshop score, and this post data is the post-workshop score. What you have to do is you just have to apply paired t-test. How? Go to analyze, go to compare means, go to paired sample t-test. I believe everybody can see this. No? I believe
Yes.
everybody can see this, and you are able to identify also that which menu we are using.
Yes, sir.
Thank you. So this is paired sample t-test. Here we have activated it. Now you will find what we have to do is our first pair. Okay. So the first pair would be like marks before and marks before we shall enter. This will be the variable one. Marks after will be the, not exactly the second, it will be entered in variable 2. However, it is same participant. Okay, here you can see participant ID has not been changed. So the participant will remain same. Only pre and post scores are over there. So this is pre and post. We do not need to put anything in the options, since we do not have two different groups now. So this identification or group differentiation also need not to be bothered, and just hit OK, and you will find the result over here. The hypothesis would be, once again, there are two different types of hypothesis. First one is in the plain English, that the workshop is of no use. And then the statistical hypothesis, the one which we shall be using in our research. There is no significant difference in the experience or in the knowledge of participants before, pre-workshop and post-workshop. Whether this hypothesis is clear to everyone? There is no significant difference in the knowledge of participants pre-workshop and post-workshop.
Yes, sir, we got it.
Okay. In plain English, what we shall be saying? The workshop is of no use. Okay. Or the workshop was not that much effective. So now I believe you people can not only see this, but you can draw results out of it as well. The very first paired sample statistics, pair 1, marks before, marks after. This you can see 20 shall remain same definitely. And then marks before and after. So paired sample correlations. Okay. And then you will find paired sample test. So paired sample test, what it says is, this is in the last, you will find the significance value. And the significance value is 0.004. So the significance value says that our null hypothesis. And what was our null hypothesis? There is no significant difference in the marks of participants pre-workshop and post-workshop. There is no significance and there is no significant difference in understanding of the participants pre-workshop and post-workshop. This will be our hypothesis. Since we have got a significance p-value is somewhere around 0.004, hence we can say that this value, this null hypothesis stands rejected. Alternatively, you can say that we cannot accept the null hypothesis. So the null hypothesis is rejected. Alternative hypothesis, there is significant difference in the pre-marks and post-workshop marks. Hence, we can say that the participants understood. Experience of participants has increased. They have learned what has been taught in the workshop. Since there is difference, there is significant difference in their pre-workshop marks and post-workshop marks. Okay, is it clear to everyone?
Yes, sir.
Okay, thank you so much. Now, once again, with a very since we are having some limited amount of time, I shall be teaching, not teaching you. I shall only be showing you one more test. Like here, we do have two groups. So this was about t-test. Now, if we have three different groups? For example, let me as we were discussing right now, we are taking the example. What if we have to compare the performance of nationalized banks, private sector banks, and government banks? So now there are three groups. So what happens is, in times where we are having three different groups, the test we shall be using would be ANOVA, analysis of variances. The full form of ANOVA is analysis of variances. So we shall be using those three, that ANOVA for three groups. Okay. So similarly, in the way in which we prepared the table of marks, here we already have this ANOVA table with us. Here it is. So this is the time. This is actually some type of data, and I have not actually used the the financial data or so. So this is time. So time of, look, you can see there are two different, here it is, come to variable view. There are course, how much time it takes to complete the course. So the course would be different types of courses. In label, you can write down anything. However, you cannot write anything over there. So here it is. I believe you people can see this course, numerics 8 character width, different types of courses. So we have 3 different types of courses over here. In values, you can see 1 for beginner, 2 for intermediate, 3 for advanced. Okay, you have to name it every time. Means at the time you are punching the data into SPSS, you have to name it. So this is the values which we have assigned. Then the time taken, time duration taken for completion of spreadsheet program. It would be like, if just for the sake of example, we have written spreadsheet program, but if you can write down anything, whatever program you want to write. So how much time has been taken by the candidate, by the participant, by the student to complete that course. Okay, so they are different. Now we want to, there could be 3 different groups. Now these 3 groups can be of anything. These 3 from anything from the demography. There could be more groups as well, but the test will remain same. Okay, so let us go to analyze once again. Go to compare means go to one-way ANOVA. You people can see, I believe. Time duration taken. So time duration taken will be our dependent list. And different types of courses will be the factor. Factor for differentiation between the 3 courses. Okay. Now you can go for contrast. Do not need to say anything. Post hoc, as of now, we are not discussing post hoc, but in post hoc, what happens is, only thing is that in post hoc, it compares 2 tests at a time. Like we are having 3 tests right now. So it will, post hoc will be compared, then 1 and 3 will be compared. So that is actually post hoc analysis and nothing specific. Now here you can, whatever you want to have, you can have descriptives, you can have fixed and random effects, homogeneity of variances, Brown forces, Welch, whatever you want, means plot. So you can have whatever you want to have. As of now, we are right now putting only on descriptives. You can also continue with the very same. Now continue, here it is, and then nothing else. You just have to hit OK and you will get the result. The result is the tables have different forms now. So the first one, it is descriptive. So beginner, intermediate, advanced, number of participants, their mean marks, standard deviation, standard error, whatever you want to. So all kind of descriptives over here. And then let us come to the ANOVA. F test and ANOVA are the same thing. F test and ANOVA are the same thing. One more thing, like Z test and T test are the very same thing. Only difference, theory, you will find the difference is very narrow, and the difference is like Z test is being applied to less number of participants, to small sample which is less than 30, and T test is applied to more than 30. However, the formula remains very same, and the applicability of the test, the results drawn are very same. Hence, in case of SPSS, now we do not have anything like Z test. Whatever we apply shall be T test only. Similarly, in one-way ANOVA, we used to write one-way ANOVA. We do not write F test over here. So ANOVA over here, the table for ANOVA you can find. So between the groups and within the groups, the sum of squares, the degree of freedom, then mean squares, F value, and then significance value. The hypothesis over here would be there is no significant difference. Okay, there is no significant difference in completing the spreadsheet course between these 3 types of groups, or by the beginners, intermediate, and advanced students, or sorry, by the beginner, for the beginner courses, intermediate courses, and advanced courses. There is no significant difference in the time taken to complete the spreadsheet course, the beginner course, intermediate course, and advanced course. This shall be the hypothesis. And by observing the significance value, I believe you people can easily understand, you can interpret that our null hypothesis gets rejected. It does not hold good. Hence, there is significant difference. We find that the difference in completing these 3 types of courses, the time taken to complete these 3 types of courses is significantly different. Is it clear to everyone? Understood? Or any kind of doubts, you can ask me right away.
I understood. Sir, I just want to know one thing. So now this
Yeah.
is showing the comparison between beginners, intermediate, beginners, advanced, and intermediate, advanced, and
No, 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 no. This F test, this ANOVA will be showing difference between all the three. Just a second. Let us go to analyze, go to compare means, go to one-way ANOVA, and then post hoc. Let us go to post hoc. And in post hoc, what happens is, let us have anyone from this, but you can have like all these are actually applicable at different places. So you can have actually they are not very much in general research, they are not very much of use. But let us have this, let us have Sharpe, let us have 2K, and let us continue from here. I believe you will find this. Here it is. If you go for post hoc, you get this. You can see this.
yes, sir. Now it is clear.
So yeah. So if you go for post hoc, in that case there shall be like I believe you can see this table, and interpretation is also like very easy. Between beginner and intermediate, the value is 0.000. Between beginner and advanced, the significance value is 0.000. You can see here it is. Between intermediate and advanced, the significance value is 0.816. I believe you can see it.
Yes, sir.
Between intermediate and advanced, the value is 0.816 significance value, which is more than our threshold limit 0.05. It means that the time taken for intermediate and advanced courses that are almost similar. There is no significant difference in the time taken to complete the intermediate and advanced course. If this would be the hypothesis, definitely it would have accepted. Yes, there is no time difference in completion of intermediate and advanced course. Okay.
But the same result showed previously in only the F value was showing that it was accepted, na, sir?
No, this 0.816, which is more than 0.05, it means our null hypothesis will be accepted. And wherever the value, here you can see the value is 0.000, which is less than 0.05. Hence, this is not accepted. This is rejected. So our null hypothesis that the time taken for completing this beginner and intermediate course, there is no significant difference. So there is no significant difference. This hypothesis will get rejected. It means there is significant difference in completing the beginner and intermediate courses. But in case of intermediate and advanced course, this fourth number point, here the value is 0.816. So though there is difference between the beginner and intermediate and beginner in advanced, the time difference is there, significant time difference is there. But in intermediate and advanced, there is no significant difference in completing the course. The time duration to complete the course is not very much different, significantly different.
Okay, sir.
So I believe that with this, the inferential statistics, we have almost come to an end, and our time does not allow us to move further. So from my side, I believe that this much is this point is over. And if you are having any more queries, please let me know so that we can discuss them.
Thank you, sir.
Thank you. Thank you so much. Anyone from Research Foundation of India? Any official over? Excuse me. Any official over here? Well, I do not find anyone. So from my side, I am very much thankful to all the participants who have participated. They have patiently learned, they have patiently watched whatever we have discussed. And I'm thankful to all of you, all the participants. I'm thankful to Research Foundation of India for conducting this workshop. And I believe that we shall be conducting the very same kind of workshops in the future as well. And we shall be solving the difficulties, resolving any kind of confusions and doubts for the students, for the researchers as well. We shall continue be serving the research fraternity. Thank you so much, everyone.
Thank you, sir.
Thank you so much.